In order to fully appreciate the number systems, you have to be pretty good at dividing. You need to have your divisibility rules down. So we have, if a and b are natural numbers, a is divisible by b if the operation of dividing a by b leaves a remainder of 0. This is the same as saying that b is a divisor of a, or b divides a. These statements can be symbolized using the following notation. B divides a, or here we have 12 divides 24, because 24 divided by 12 is exactly 2. It's a little backwards, but you get used to it. So, we have a divisibility rules paper posted on our class site. Please use that to see which of the following statements are true. Is this big number divisible by 4? Well, when you divide by 4, you only need to look at the last 2 digits and say, are those divisible by 4? Well, the 8 is, so we can get rid of that, but 6 is not divisible by 4, so we're going to get a no here. To figure out if something's divisible by 9, we have to add all the digits up. So we get 4 plus 1 is 5, plus 1 is 6, plus 9 is 15, plus 7 is 22, plus 0 is 22, plus 6 is 28, plus 4 is 32, plus 1 is 33, plus 3 is 36. And since the sum of our digits is 36, which is divisible by 9, or 9 divides 36, we know that 9 divides this big number as well, so this one's going to be a yes. And lastly, if something's divisible by 8, the last 3 digits are going to be divisible by 8, and we see that 840, 800 is divisible by 8, and so is 40, so this is going to be a yes. So those divisibility rules are really worth knowing. Now we have a definition. A prime number is a natural number greater than 1 that has only itself and 1 as a factor. For example, greater than 1, so we start at 2. 2 is a prime number. 3, 5, 7. All of these are prime numbers. Then we skip up to 11. All of these are prime numbers because they only have 1 and themselves as a factor, which helps us with our definition of a composite number. A composite number is a natural number greater than 1 that is divisible by a number other than itself and 1. Or a composite number is any number that is not prime. It's just all the numbers that are not prime. So, I'm going to remind you for a second how to take the prime factorization of something because it's important to know. I could start, if I have 700, I could start with 7 and 100, then I could drop that down to 50 and 2, and then that's 25 and 2. That's pretty quick. But if I want to prime factorize 700, I could also start with 70 and 10. Here's 2 and 5. Here is 2 and 35, which is 5 and 7. And you notice that I end up with, this is 5 and 5. I end up with the same prime factorization. So no matter how you start, you still end up with 2 2s, 2 5s, and a 7. No matter how you split it up. That is 700. And now let's look at the prime factorization of 120. Do this one on your own for practice. 120 is 10 and 12. 12 is 4 and 3. 4 is 2 and 2. 10 is 2 and 5. And that is a reminder on prime factorizations. A definition here. The fundamental theorem of arithmetic is that every composite number can be written as a product of prime numbers in one and only one way, if the order of the factors is disregarded. And that's the same no matter how you factor 700, you still end up with the same prime factorization. You still end up with 2 2s, 2 5s, and a 7, regardless of order. Now, the process of finding the greatest common factor or divisor of 2 or more numbers is you write the prime factorization of each number, select each prime factor with the smallest exponent that is common to each set of prime factorizations, and then form the product of the numbers from step 2. For example, if we have these two, let's split them up. 216 is 2 times 108. 108 is 2 times 54. 54 is 2 times 27. 27 is 3 times 9, which is 3 times 3. So we end up with 2 to the third times 3 to the third. Do the other one in blue. 234 is 2 times 117. 2 times 117. And 117 looks prime, but it's actually not, because 7 plus 1 is 8 plus 1 is 9. This is divisible by 9, which we can make it easier by saying it's divisible by 3. Divide it by 3 first, which will be 39. And then this is divisible by 3, which will give us 13. So we have a 2, 2 3s, and a 13. And so if we're looking for the greatest common factor, we write this one as 2 times 3 squared times 13. And our greatest common factor is going to be, they have 1 2 in common, and they have 2 3s in common. So we end up with 2 times 3 times 3, or 2 times 9, or 18 is the greatest common factor here. Now we have a little word problem. We have, for an intramural league, 40 men and 24 women must be put into teams of equal numbers of men and women. Can this be done? How many teams will there be? How many men are on each team? How many women? So, we want 40 men and 24 women to be put into teams of equal numbers of men and women. How many teams will there be? So, first thing we do is we split up 40 and 24. This is 4 and 10, 2 and 2. 10 is 5 and 2. So we're left with 2 cubed times 5. With 24, we have 2 and 12, which is 2 and 6, which is 2 and 3. So we're left with 2 cubed times 3. And we see that they only have a 2 cubed in common. So we are going to be left with 2 cubed is 8. So their greatest common factor is 8. Which means we can have 8 teams. There'll be 8 teams. And how many people are on each team? Well, let's just divide the number of people by that. So 40 divided by 8. There will be 5 men on each team. 24 divided by 8, and there will be 3 women on each team. Spelled that wrong. 3 women on each team. And that is a place where the greatest common factor could come in handy. Now we also have finding the least common multiple using a prime factorization. Right, step 1 is writing the prime factorization itself. Step 2, select every prime factor that occurs and raise it to the greatest power for which it occurs in these factorizations. Step 3, multiply to get your least common multiple. So, I will do 144 and 300, and I'll leave the other one for you guys to try. Well, 144 I know is 12 times 12. 12 is 6 times 2. 6 is 2 times 3. 12 is 2 times 6. 6 is 2 times 3. So with 144, I am left with 2 3s. And 1, 2, 3, 4 2s. And with 300, I have 100 times 3. 50 times 2. 25 times 2. 5 times 5. I'll write the 300 number in yellow. So we have 1 3. We have 2 2s. And we have 2 5s, 5 squared. And so our rule is take the prime number with the highest power. So out of the 3's, we have a 3 squared is the biggest. Out of the 2's, we have a 2 to the 4th is the biggest. And out of the 5's, we have a 5 squared is the biggest. And then if we multiply this together, we'll get the least common multiple of 144 and 300. So 2 to the 4th is 16. 3 squared is 9. 5 times 5 is 25. 9 times 16 is going to be 144 times 25. And 25 has this cool property where if I divide 144 by 4 and then add 2 zeros, I'll get the right answer. 144 divided by 4 is 36, so my answer is 3600. And so the least common multiple of 144 and 300 is 3600.